I adore little Rachel.
Oh my goodness.
Okay, this is the class that's going to cooperate so that I can record this lesson nice and clearly for you all in the other class. So we are ready to learn the 3 ultimate properties of logarithms. You will live and die by these 3 rules. Okay? Well, it'll be your logarithmic death if you don't follow them. We'll put it that way. Okay. These 3 rules explain what you do with logs, as you'll notice when you have more than one log in a problem. Okay. Now, let me remind you, or actually get you to tell me again. Logarithms represent what? Exponents. Thank you. So if logs represent exponents, when is it that we add, because this is a log plus a log, so you're adding an exponent plus an exponent. When is it that you add your exponent? When you're doing what mathematical operations, the variables? If you're multiplying the variables, don't you add the exponents?
Yeah.
So if this, when a log says a log plus a log, those are exponents, it means you really actually are going to multiply the 2 quantities, the m and the n, you're going to multiply those 2 quantities inside. So when you see a plus sign with logs, you multiply. So therefore, what's it going to mean when you see a minus sign? You divide, because when we're working with exponents, we divide. So now, how do I know which one over which one? Yeah, the positive one divided by the one that's been subtracted. So it'll be, yes, in this case it'll be m over n. Yes, whatever's filled in there divided by the whatever's filled into the other log. Yes. So m and n could be numbers, they could be x plus 7, they can be quantities, they can be anything. Okay, then the biggest, the ultimate rule of all. Have you ever heard my pre-calc or calc students, or have you said anything about logs? Has anybody said have you plugged yet?
No.
And you haven't talked to them about it.
Nope.
Yeah, that's not the first conversation I had.
It says, and I will prove this to you momentarily, it says you can take the power and you can multiply it down in front of the log. So I can actually take that exponent and stick it out front and multiply it. We call that the plug rule, because it spells plug.
That's so cool.
Yep. Okay, let me give you an example of that. So that one's the hardest one to believe. It doesn't seem like you should be able to do that. So let me prove it to you. If I gave you log base 3 of 3 to the 4th power, what is this rule saying I can do with the 4? And this rule says you can put the 4 down front. Okay, so now, you all just learned how to evaluate logs last assignment. What happens when the bases are the same? Here we got a base 3, so that left side equals 4. The right side is 4 times something. Well, I got a log base 3 of 3 to the what power?
1.
That would technically be a first power. So therefore, that log is equal to 1. And so, aren't those 2 things equal? Does it 4 equal 4?
Yes.
Yeah. So the plug rule works. We will use the plug rule both ways. Sometimes you will have a number down in front of the log and you don't want it down in front of the log, so you will choose to move it back up and make it the power on the log. That rule can go either direction. You'll find it useful either way. Okay, so as you may have noticed from that worksheet I gave you, there's multiple logs in most of those problems. So how do we solve that? Okay, here's basics. I think this will be common sense to you. If I give you a log base 6 of 2x plus 5, and then I give you a log base 6 of 9 minus 4x, what's your gut instinct say you should logically be able to do there?
Get rid of the log 6.
Yeah, it's the same thing as when we made common bases. You could, once you have the same bases, you can drop them off. In this case, it's the same thing. If they both are a log base 6, same exact log on both sides, then we know the arguments inside must be equal, and you can set 2x plus 5 equal to 9 minus 4x. So your goal is always going to be to get it down to the same log on each side, and then you can set them equal. And now it's just normal solve for x. So which way do you want to move the x's? I'm gonna move left. If I add 4x, that's gonna give me 6x. If I subtract 5, I'm gonna get 4, and 4/6 is really 2/3. Now, here's the downside. You're solving for x. X was inside the log.
You have to put back.
You have to put it back in and check that it would make a positive number, because remember, we always have to have the log of a positive number. So you have to go, if I put 2/3 in this 2x plus 5, if you actually filled that in there, and you can just eyeball it, am I going to get a positive answer? It's all positive, so sure. 2 times, whoops, sorry. I wrote my parentheses wrong, you're right. But still, either way, aren't those all positive numbers? 2 times 2/3 plus 5 is all positive, so yeah, that's good. It's this one over here that's worrying me a little bit. Here I may actually have to do a little number crunching. If I take 4 times 2/3, that's subtracted. That's going to be 9 minus 8/3. Well, I think 9's still way bigger than 8/3. 8/3 is only 2 2/3, so yeah, it's still going to come out positive. So we're okay either way. So that one checked, answer. This is not good. This one right. So you're going, well, that was too easy. She's insulted our intelligence, and we want more challenge.
No.
Yeah.
That's enough for you guys.
We've only just begun. All right. So our second problem, you notice we have 3 logs.
You take the stuff in front of you.
Okay. Your goal is you have to get each side worked down so there's only 1 log on each side, and you can use those 3 rules. So on the left side, I have 2 logs. Which of the 3 properties I gave you applies here? The first one that tells you what to do when you have a log plus a log. It says do what? Multiply. So bingo, you are going to have to FOIL. Yeah. Yes?
What if it's like log 6 and log 7?
Ah. Okay. A, you couldn't do anything. They have to be logs with the same bases, but I'm not going to give you different bases. That's not going to be an issue. Good question. But no, I won't be that
Will
easy.
they ever be?
No.
Okay. Will we ever learn in like college?
I can't honestly say I've hardly ever, I will be teaching you what's called a change of base formula eventually, but not something you hardly would ever see. You almost always work in the same base. Okay, so I'm assuming, can we all FOIL that now? So what's the middle term going to be? It's going to be a plus 2x and a minus 15. Okay, so left side's good. Left side's 1 log. Right side. It's really close, it's 1 log, but
You got a plug.
I can't have that 2 in front.
Got a plug.
So where am I allowed to move the 2 to? Yeah, you are allowed to take the number using the plug rule. It's actually becoming 3 squared. It becomes the power on the 3.
So it becomes 9.
So yes, it will actually become a 9. So I have a log base 7 of 9. Now, you've got the same log on both sides. So once you've got that down, we got log base 7, yes, we can drop the logs off of there and set the powers, or the arguments equal. The quantity inside a logarithm is called the argument. Okay, now, this is normal algebra we've been doing since November. How do I solve that? It's quadratic. You have to set it equal to 0. So if I subtracted 9, that would give me minus 24. I have a vote for 6 and 4. Are you buying that?
Yep.
So plus 6 and minus 4 looks like it's going to work. It'll get us a positive 2 in the middle.
Then we have to determine.
Okay, so then we need to solve those quantities. Can we solve those in our heads? Okay. And are you done? Okay. Should you assume that all negative answers are wrong and all positive answers are right?
No.
No, you should not make that assumption.
Can we assume that all
No.
I know.
Because what if it was a 9 minus x, If you put a negative number in there, it'll become a plus. So you cannot assume that negative numbers are always going to be bad and positive numbers are always going to work. We got to check it. Now, I don't expect you to write out a check. I just expect you to go, okay, if I stuck negative 6 back up here in the original problem, if I had negative 6 plus 5, that's negative 1. It crashed and burned right there. I can't have the log of negative 1, so that answers out. So then I would go try the 4. Is 4 plus 5 going to end up positive? Then you go to the next quantity. Is 4 minus 3 going to end up positive? Yes. There was no variable over here in the third one, so yeah, 4's good. That wasn't horribly painful, right? Yeah. Is that as hard as it gets? Probably not. Okay, here is one of my most missed problems. Oh my heavens, most missed problems. Can't tell you how many times this one has been missed. Okay, the big question is, why is that problem different than the one we just did?
No, because the log was...
Okay, the log's going to have bases, you're right there, but the key thing is, notice what it's equal to. It is equal to a 1, not a log of 1, it's equal to a 1.
Okay.
So therefore, we aren't going to be able to just set the two quantities equal because we don't have logs on both sides. We're going to have to use something else you already know. But you still, first thing, have to get it down to 1 log on each side. And so Josh said I should multiply. Do you all buy that? Okay. So when I multiply, what will I get? I'll get x squared plus 3x equals 1. I can't set x squared plus 3x equal to 1 now because there's no log over there. So what did I just tell you last, which you guys just learned today, but everybody else learned last class, if there's a log on one side?
Oh, so you got exponential form.
Yes, you change it to exponential form. But how do I change it to exponential form? There isn't a base. Bingo. If there is no base, it is naturally a 10. So think of that as being a 10 there. So what do you have? 10 to the...
X squared.
What's the exponent? 10 to the first is x squared plus 3x. I changed the exponential form. Okay, now it's a normal solver. How do you want to solve it? I would subtract that over and say x squared plus 3x minus 10. And then, golly gee, can we factor it again? Plus 5 and minus 2. And therefore x would equal negative 5 and 2. Are we done?
No, we gotta check it.
No, we gotta check it.
Not long enough.
So, if I sub in negative 5, will that work?
Yeah.
Log of negative 5?
No,
So that one's bad. If I put 2 up here in the original problem, log of 2 is positive. Log of 2 plus 3, positive. So 2 is the correct answer. If you had to cancel them both out, yes, there would be no solution. Yep. And that can happen. Won't tell you that you won't see that. So we should note on this one, it was a change to exponential form. Okay, that's a good place to pause.